Welcome to your channel that teaches you corporate English every day.
Section 1. Early failure in coded indecisions. Not in code and backend projects. Failure does not begin at the moment of a crash, an outage, or an incident. It begins silently in the very first conversations, in the way requirements are framed, the way ambiguity is tolerated, and in the way risk is postponed. When a team starts building without a clearly defined perimeter, without constraint-driven architecture decisions, without a declared source of truth, and without maintenance planning, the failure is already present, only not yet visible. What you later call a back-end failure is simply the delayed exposure of a mistake that was already written into the project's logic. You can recognize this kind of failure before a single line of code is shipped. Just by listening to how people talk about the system. If stakeholders are debating features while engineers are already implementing, there is missequencing. If the business cannot articulate why the system exists, but engineering is already discussing how to build it, the order of reasoning is inverted. If someone says we can add that later, it means the scope is not closed, which means the schedule is imaginary. These linguistic signals are not noise, they are diagnostics. A simple but illustrative example. Consider a fintech building a transaction processing engine. If the team begins discussing endpoints and storage before understanding regulatory constraints, auditability, fraud detection latency, and reconciliation flows. The backend is being architected for a theoretical world rather than the actual one it will operate in. The architecture might work technically but fail economically, legally, or operationally once deployed. That failure is not born at runtime. It was structurally embedded when constraints were neglected. Another example. A logistics platform begins development while still unsure who is the source of truth for delivery status. Systems start updating status independently. For months, everything appears fine, until a high-volume period exposes contradictory states, causing operational chaos, refunds, and SLA penalties. Nothing changed in that moment. The contradiction was accepted months earlier. A senior professional does not wait for these problems to surface. They detect failure at the language level, at the sequencing level, at the ownership level, long before code execution. Corporate. English vocabulary. Section 1. Structural failure. A failure caused by foundational decisions, not runtime behavior, missequencing, executing implementation before clarifying intention and constraints. Constraint-driven architecture. Architectural choice justified by business and technical limits, delayed exposure. When a mistake exists early but surfaces only later in production. Scope not closed situation where requirements can still grow after build begins. Theoretical architecture. A design disconnected from real operational constraints. Economic failure of design, when a system works but is not viable to run in reality. CICTON. 2. The linguistic fingerprints of a weak backend project. 1. Of the most powerful skills in backend leadership is the ability to identify risk through language. Weak projects have recurring linguistic markers. You hear people say, "we will figure it out later," which is another way of saying we are inserting risk intentionally. Here, this is just a quick fix, which is code. For we are choosing short-term convenience over architectural stability. You hear if anything goes wrong, we patch it, meaning there is no prevention mindset, only reactive optimism. Strong back-end projects sound different. You hear phrases like, what is the boundary condition? What constraint does this decision serve? Who owns this field? What is the rollback path? What is the cost of maintenance? The health of a back-end can be diagnosed by the sophistication of the questions, not by the prettiness of the code. Failures do not begin with broken code. They begin with shallow thinking masked by speed. Consider a real-world scenario. A healthcare platform integrates with 3 third-party providers for lab results. In a weak team, developers say, we will handle differences later. In a strong team, someone asks, what is our reconciliation rule if vendor A and vendor B disagree? The difference between those two sentences is not vocabulary, it is maturity. One team builds for the happy path. The other designs for the world as it actually behaves. Even cultural cues expose risk. In immature environments, objections are treated as obstruction. In mature ones, objections are treated as information. When senior people raise concerns and the room responds with annoyance instead of curiosity, the organization is choosing blindness. A backend does not fail because someone didn't know. It fails because someone knew and the signal was socially suppressed. Corporate. English vocabulary, Section 2, risk inserted by deferral. When unresolved decisions are pushed into the future, reactive optimism, assuming problems will be fixed later instead of prevented. Boundary condition, the explicit limit of what the system is responsible for. Reconciliation rule, the rule that resolves conflicting data from multiple sources. Happy path design, designing only for ideal scenarios without handling failures. Signal suppression, cultural behavior that discourages or ignores early warnings. Maturity of reasoning, quality of decisions reflected in the questions being asked to CCTON3. Why back-end failures are financial decisions disguised as technical outcomes. Organizations believe back-end failure is a technical matter, but in reality it is a financial phenomenon caused by choices made upstream. If a system is built without defined ownership, the cost of conflict later is not technical, it is monetary. If a system is designed only for launch and not for long-term maintenance, the cost is not in deployment. It is in years of support, outages, and manual intervention. What looks like a code problem is actually a budget leak with a technical interface. Imagine a core banking change executed without unified data authority. The bank later spends millions reconciling accounts manually due to inconsistent rules. That is not technical debt. That is financial liability created by governance failure. Or take an IoT manufacturer that ships edge software without deterministic timing guarantees. A recall later costs more than designing it right would have cost originally. The damage is financial. Even though the symptom is technical, this is why senior leaders treat back-end discussions as risk underwriting exercises, not coding discussions. They ask, what is the cost if this assumption is wrong? What is the cost of rewriting later versus deciding correctly now? What is the financial payload of a bad data decision? When you begin thinking this way, back-end architecture stops being a technical preference and becomes an economic design problem. Back-end is not a one-time expense. It is a living cost center. The team either designs a system that pays dividends in efficiency or one that accumulates interest in chaos. The collapse is not accidental. It is economically pre-programmed. Corporate English vocabulary section. 3. Financial liability disguised as code. Cost created by governance errors that later appear as technical issues. Cost of misownership, monetary impact of unclear data authority. Maintenance as a cost center, recognizing that running, not building, drives expense. Risk underwriting, evaluating decisions by their financial downside. Not only feasibility, economic design failure. Architecture that is technically valid, but financially unsustainable. Interest-bearing technical debt, design shortcuts that grow more expensive over time. Governance failure with technical surface decisions that look technical but originate in management errors. Asterisk. Final closing. Spoken style in English, same tone as the lesson. Before we close, I want you to notice what we did here. We did not analyze failure through code. We analyzed failure through thinking, governance, language, and decision structure. That is what senior people do. Back-end failures do not appear suddenly in production. They are planted quietly at the beginning when boundaries are missing. Constraints are ignored, truth is shared, maintenance is not considered, and speed is celebrated without direction. What you later call a back-end issue is simply the late discovery of an early mistake. The reason we examine these mistakes in English and not only in technical language is deliberate. This kind of reasoning is exactly what appears in real meetings. Funding discussions, architectural reviews, and postmortems in global companies. You are not only learning how to see risk, you are learning how to talk like someone who sees it early. Using the type of English that exists in high-level decision environments. If you internalize the principles we covered, listen to language. Map constraints before solutions. Define ownership before data moves. Design for the lifetime, not for the launch. And treat speed as a liability if direction is undefined. then you will start detecting back-end failure before others even see symptoms. That is the real skill, not fixing what is broken, but preventing what would break later. You now understand how senior professionals think about back-end systems, not as code bases, but as long-term financial, architectural, and organizational commitments. Keep training your brain to look upstream and keep training your English to express that thinking with clarity and authority. That is how you evolve from someone who works inside projects to someone who governs them. End of session.